Hello, Algebra 1 ladies. In an effort to save some time in the class, we're going to go over the problems for Lesson 9798. Lesson 9798 had the most points of any lesson we did this semester. So it is going to have, getting these problems right is going to have the greatest impact on your score of any one of the lessons we have done. So if you want to raise your grade, you will go back and you will redo lesson 9798 with the corrections and with the fields here. Now, part of the problem that we had with this pod was that some of you were skipping steps. It just meant that you were doing well. You understood what you were doing, but because you were skipping steps, you weren't putting the steps in the proper place in the blanks. So this is a guide to show you where to put those steps in at so that you can get the most points possible for your for this lesson. All right. So I'm going to go through that and help you with that. The other thing that you can do is if you put the correct final answer in, I will give you credit for the whole problem. All right. So let's begin with problem number 1. We're going to work through each one and we're going to go over what goes in each blank and why. So we have to use the Pythagoras Theorem to find P. So we're going to remember the formula a squared plus b squared equals c squared. C is the hypotenuse. The hypotenuse is the one that is across from the right angle. So it's always the longest side of the triangle. So we are going to put in here our squares. So that's going to be 5 squared plus 6 squared plus p squared. All right. So now we're going to calculate the squares. 5 times 5 is 25. 6 times 6 is 36. And we still have p squared. We can't really calculate it because we don't know what that is. 25 plus 36 is going to be 61. We still have p squared over here. We can't do anything with it yet. So now we're going to apply the radical. This sum was where we added these together. We're going to apply the radical by putting square root of 61 on this side and the square root of p squared on this side. So when we square everything here, we can't reduce this square root of 61, but we can cancel out the 2 and the radical sign here, leaving just a p. So this remains the square root of 61. That's all we can do here, okay? Check it. They're all correct. And it will be a lot easier if you put everything in the blank for me to grade it and give you the proper credit than just to do the last one, okay? I would rather you fill this all in. That's why I'm showing it to you. Next one, same thing. We do the 2 sides and then the hypotenuse. So we have q squared is this side. I always do the upright and then the base for those of you that want to make sure you have them in the right blank. So that's going to be 13 squared here. So now we calculate. We can't do anything to the q. It's still going to remain the q. This is going to be 144, and 13 squared is 169. We're going to subtract 144 from both sides. That gives me q squared is, oops, I didn't put my square in. Q squared is equal to 25. So that tells me if I apply the radical, I'm going to have square root of q squared, and then I'm going to have the square root of 25. We know the square root of 25 is 5. Okay. Next problem. Let's check that first. And you can see everything that is in there is correct. So let's move on to number 3. So we're going to use the Pythagorean theorem to find D. Same thing that we've been doing. We just do upright, bottom, hypotenuse. So the upright is, actually I'm doing the bottom this time, so I did do it a little differently. Sorry for that. 8 squared, 15 squared, but that's why I'm showing it to you, so you know which blanks to put what in. And D squared is the hypotenuse. Alright, we know that 8 squared is 64, 15 squared is 225, and we still have D squared here. We add those together and we get 289 is the same as D squared. Oops, that's not a square, is it? There we go. Now we apply the radical 289 and the radical here to D squared, and we find that 17 times 17 is 289, so 17 is the answer for D. And we check it. Voila, it's all correct. It's not super hard, ladies. We can do this. Same principle, only this time we have K for the upright. K, let me put the square in. And then I have 4, we put the square in. And then we have the hypotenuse, which is 6. So I put the square in for that. And that remains K squared. This becomes 16, and this becomes 36. So I'm going to subtract 16 from both sides. That leaves K squared is equal to 20. So I apply the radical to K squared and to 20, and I find that K, you know, we can't, it's the square root of 20, but I can reduce the square root of 20. The square root of 20 is the same thing. We put it over here. This can become this times this. We know the square root of 4 is 2, so that becomes 2 times the square root of 5, and that's what we would put down here. 2 times the square root of 5, and then we'll check it, and they're all correct. Next one. Well, we're on number 6. Let me clear this over here just in case we need it. Same thing, ladies. We're just doing the same thing over and over and over and over again to this Pythagoras theorem. So we have the upright, 5 squared, the base, 12 squared, the hypotenuse, C squared. 25, 144 is still C squared. Alright, so 25 plus 144 is 169 is equal to C squared. When we take the square root of 169, we find that 13 times 13, C squared is equal to 13. Or 169, we unsquare it, we get that 13 is equal to C. We check it, it's all correct. Notice how I took a step out, right? I removed applying the radical, so the 169 equals C squared. The next step would have been putting this over the top, canceling this, and solving this. That makes 13C your last step. Next problem. Use the Pythagoras Theorem. Let me erase all this so we can have it ready. Another Pythagoras Theorem. Imagine that. The whole point of this was to have you do the steps over and over and over again until you knew Pythagoras Theorem. So we're going to do the upright squared, the base, the base is 8 squared, and then B is the hypotenuse squared. So that's going to be 36 plus 64 is B squared. We add that together, that's 100. Come over here and we say 100 equals b squared. We apply the radical to both sides. That cancels. So that's left us a b over here. Square root of 100 is 10. So 10 is equal to b. We check it. They're all correct. All right, so let's erase this here just in case I need more room, which I probably will. Again, we're going to do the upright squared, the base squared, and the hypotenuse a squared. That's going to be 9, that's going to be 16, and that's still a squared because we don't know what the variable means. But we add those two together. 9 plus 16 is 25, right? We come over here and we say 25 equals a squared. We take the square root of both. That cancels. That leaves us a. Square root of 25 is 5. So 5, we check it. Everything's correct. Number 9. Do you think we kind of understand Pythagoras Theorem yet? I think we're getting there. So again, this time it asks us to do a little bit more work on our own. It doesn't remind us anything. So we have to do it ourselves. So we have, where am I at? I'm on number 9. I've skipped ahead a page. So I have f squared. I did the base first this time for some reason. And then the upright. And then the hypotenuse. Alright, so I still have f squared here. And this will be 25. And then that would be 225. So if I subtract 25 from both sides, then that's going to be 200 here. Because 225 minus 25 is 200. So this is going to be the square root of 200 right there. And if I come over here and simplify the square root of 200, I'm going to get square root of 2 times the square root of 100, right? 2 times 100 is 200. I know that's going to be 10. 10 times the square root of 2 is my answer. 10 times the square root of 2. Check it. It's all correct. Now, if you put these in the wrong place, let me just show you here. If you were to put the wrong number, if I were to put 5, come on. Well, it's not going to let me because I got it all correct. I'm going to do this one wrong, okay? I know that I have r squared, and the reason, here's your indicator to know that r squared is here. The r is right here. So I left the r on the outside. So when you have a variable here, but if you ever put it in the wrong spot, right? So I'm going to do 6 squared here, which I know is wrong because r squared should go there. R squared here, and then that would be 10 squared. I'm going to keep going. That'd be 36. That would stay r squared. This would be 100. I'm going to subtract 36 from both sides. It's going to give me 64 here. Square root of, actually let's be the square root of, no, that'd be right, 64. And then this would be 64. Square root of 64 is 8, right? So this would be 8. So now I'm going to check it, and it tells me that these are wrong. But this answer down here is right. So I did it right. I just put the sides in the wrong place. So just leave it like that. All right, you've got the right answer. Just leave it. Don't redo it. Don't try again. Just make a note of which one it is. It's number 10. So I would write number 10 down on my piece of paper is correct. Skip it when it comes back around. Okay? Because you got the final answer correct. You could go back in here and redo this and say, oh, well, I know this is going to be r squared because I just swapped places. And this is going to be 6 squared. And then you would just change this down here to r squared 36, right? Now check it. Okay, now everything is correct. But it's going to ask you to do it again when you go back through. Just don't. Just leave it like that. All right? Just leave it like that. 10 is correct, so skip it. Go to the next problem. Following problems are from previous lessons. All right, so now we're getting into the review portion of our practice problems. So Wendy drove at 60 miles per hour. Thus, she made the trip in 1 hour, less than it took Deborah because Deborah only drove at 50. How long did each of them drive and how long was the trip? So I have to write the equation for equal distances because Wendy drove it at this speed, Deborah drove it at this speed. But it's the same trip. So that means that the rate of Wendy, subscript variable please, times the time of Wendy is equal to the rate of Deborah times the time of Deborah. That's your equation that you're doing. The rate of Wendy drove at 60 miles an hour, so the rate of Wendy is 60. The rate of Deborah drove at 50, so the rate of Deborah is 50. The time of Wendy is going to be, she made the trip in 1 hour less than it took Deborah. So it's the time of Deborah minus 1. That's what we have so far. So we can go ahead and fill in the rate of Wendy is 60. The rate of Deborah is 50. We still need to calculate time and then distance. Right? So what we're going to do is we have a substitution value here. We're going to take this equation and write it on our paper. RW/TW equals RD/TD. And now we're going to drop in our values. RW is equal to 60, so 60 goes here. RD is 50, so 50 goes here. The time of Wendy is TD minus 1, right? And we don't know the time of Deborah. We just write it in. Now we calculate. 60 TD minus 60 equals 50 TD. I subtract 60 TD from both sides. I get negative 60 is equal to negative 10 times the time of Deborah. Divide both sides by negative 10. And I get positive 6 is equal to the time of Deborah. Now I have the time of Deborah. That's 6. The time of Wendy is the time of Deborah minus 1. 6 minus 1 is 5. The distance is going to be either Wendy or Deborah, their rate times their time. So 60 times 5 is 300. Boom. Let's check it. Perfect. All right, do you see how we're doing that? Let's move on. Let me clear this page. Find 4 consecutive integers. All right, 4 consecutive integers. N plus 1, n plus 2, n plus 3. That's 1, 2, 3, and 4. All right, and then let's put equal out here so we can put their answer. All right, so write consecutive integer equations. We just did that. So that's n plus 1, n plus 2, n plus 3. There's our equations. Now we write the equation from the sentence. Find 4 consecutive integers such that 4 times the sum of the first and fourth. The first is n, the fourth is n plus 3. Is 1 less, so minus 1, oops, just 1, than 9 times a third. So 9 times the third is n plus 2. n plus 2. Now we solve it, okay? So that would be 4 times n plus 3 equals 9 times n plus 2 minus 1. That's going to be 2n plus 3. So 8n plus 12 is equal to 9n plus 18 minus 1. That's going to be 17. So if I subtract 12 from both sides, I get 5 over here, and I subtract 9n from both sides, I get negative 1n over here. Divide both sides by negative 1, n is equal to negative 5. So n is equal to negative 5. That means my 4 consecutive integers are negative 5, negative 4, negative 3, and negative 2. We'll check it. 100%. Next one. Clear the page. All right, line A is on the x-axis. It crosses the x-axis. So x is equal to, it crosses the negative 2. Negative 2. All right, so this one I have to do a little bit of math. So the y-intercept is going to be 0, 2. So it's at the negative 2. The slope is going up, so it's positive, so it's going up. Here's my next point, up 1, and the next place it crosses is where I count to. 1, all right, 1, 2, 3. Up 1 over 3. So 1 over 3. So therefore, y is equal to 1 over 3 x minus 2. That's the slope of the line. Check it. That's all perfect. Number 15. We're almost done. So we have to evaluate. So let's do the numerator first. Negative b plus or minus the square root of b squared minus 4ac. All right. A is 2. C is 2. B is 5. So negative 5 plus or minus 5 squared minus 4 times that. So negative 5 plus or minus square root of 25, that's 8, that's 16, minus 16. Okay. 25 minus 16 is going to be 9. So negative 5 plus or minus the square root of 9. So negative 5 plus or minus 3. That's my numerator. Negative 5 plus or minus 3. Denominator, 2a. A is 2. 2 times 2 is 4. So my solution, that would be 4 for my denominator. So I would have negative 5 plus 3 over 4 and negative 5 minus 3 over 4. All right, negative 5 plus 3 is going to be a negative 2 over 4, which equals a negative 1/2. So that's one solution. And my other solution, being negative 5 and negative 3, is equal to negative 8 over 4, which equals a negative 2. So my other solution is negative 2. Check it. So I know these are right, so I'm just going to put them in the different order. And let's do negative 2 first, and then let's do negative 1/2 second, and now check it. All right, they were just in the wrong spot. Not a big deal. So now I know that not only number 10, but number 15, I got all correct. So I'm just going to say skip number 10 and number 15 because I got them all right, and I'm not going to rewrite them again. All right, number 16. So I have to remember that the circumference of a circle is d, which is the diameter pi. And for a half circle, we divide that by 2. So the diameter here, this is 6, the radius, so the diameter is 12. So I have 12 pi divided by 2 for the first half circle, and 12 pi divided by 2 for the second half circle. And this half circle, the radius is 12, so that's going to be a diameter of 24 pi divided by 2 for that bottom circle. So that's going to be 6 pi here plus 6 pi here plus 12 pi here. And that's going to equal 24 pi. So let's write that. The perimeter of one of the smaller half circles is 6 pi. The larger one is 12 pi. 2 times 6 pi plus 12 pi is 24 pi. Check it. Perfect. Alright, so this one we've already done. We're going to skip it. This one we've already done. We're going to skip it.